3. So what we learn in our chapter number 3? We have many things, just like that chapter was named on atomic structure. Meanwhile, the structure of an atom is the basic part we are studying in our chapter. Am I right? So here was a definition about atomic models. Meanwhile, how structure of an atom is basically described by different scientists and by their different theories or model as well. So first of all, we have seen the Dalton model, which are describing about the structure of an atom, but a few drawbacks were left in his model. Then we started towards our Rutherford experiment. He also do a great work in the field of chemistry in the structure of an atom. But although he draws some defects in his model, but after these defects was resolved by Neil Bohr in 1930, as he gave his Bohr atomic theory, which was 95% giving us a true model for an atom. Am I right? But a very little aspect, like three-dimensional aspect of an atom, was not described by a Bohr model. Then fourth number, quantum mechanic model. The quantum mechanic model is based on a modern science model which describes the structure of an atom, and it mainly incorporates with that principle of quantum mechanics. So what do you mean by quantum mechanics? Just tell me.
And as we had described in the previous lecture, quantum mechanics describes the behavior of light
Good.
and matter,
Very
atomic and subatomic level.
Very good. And the main difference between the quantum mechanic model and Bohr atomic model was that Bohr atomic model describes the formation of shell or orbit, whereas the quantum mechanic model describes the world of orbitals. Understand that? Meanwhile, the Bohr atomic model specifically prescribe a specific region in which electron exists, whereas the quantum mechanic tell us that it will not a specific region. It will define the probability region in which a electron are more likely to be found, and that region were named as orbital. So that was a little review for our chapter number 3, that is atomic structure. As we are starting our fourth lecture of this chapter, that is the fourth model, that is the Heisenberg Uncertainty Principle. So firstly, Heisenberg is the name of the scientist. He gave a very new and very fundamental concept of structure of metal dealing with the quantum mechanics as well. So Heisenberg Uncertainty Principle is one of the fundamental concept of quantum mechanics and is named after the German physicist Werner Heisenberg, who formulated it in 1927. Meanwhile, that principle, that law, were invented in 1927 by a scientist that was a German, and his name was Werner Heisenberg. Okay, so what his principle states, what his principles say, this principle states that, meanwhile, the Heisenberg uncertainty principle says that it is impossible to simultaneously determine the exact location and future trajectory of an electron. Meanwhile, he said that it was an impossible condition in which you can determine the two things in the same time. The first thing is exact location, and the second thing is future trajectory of an electron. Firstly, you will tell me that what do you know about future trajectory?
Future trajectory, where it will go in the future, like
Good.
if we are going to use a rocket.
Future trajectory refers to the anticipated path or course something will follow in the future, often in the context of a movement, development, or change. Meanwhile, anything which happens in a future, that will be known as future trajectory. So here is a word given, future trajectory of an electron. Meanwhile, we don't know where an electron have to move. An electron should move in an electron rather move in second shell, an electron rather move in first shell, an electron rather found in third shell, an electron rather found in fourth shell. Meanwhile, we have no idea about the jumping transition of a electron, where an electron have to jump in future. That is the known as the future trajectory of an electron. So what the Werner Heisenberg says that it is impossible to simultaneously determine the exact location and future trajectory of an electron. As a result, protein of the electron orbit around the nucleus becomes an irresistible challenge. What do you know about irresistible challenge? Are you listening?
Yes, ma'am, I'm listening. I don't know what is an irresistible challenge mean.
Irresistible challenge mean the thing which can never be happen easily. Understand that? Meanwhile, a challenge which is irresistible, जिसको आप ये भी कह सकते हैं इन सिंपल वर्ड्स नाकाबिले तलाफी। मीनवाइल आप उसको दोबारा से रेजिस्ट ही नहीं करवा सकते, ठीक है। तो ये आपके पास क्या था, एक चैलेंज बन गया था एट दैट टाइम अकॉर्डिंग टू हेजनबर्ग वर्नर, क्या ये दो काम साइमल्टेनियसली का मीन होता है एट अ टाइम, मीनवाइल एक ही टाइम में आप ये दो चीजें नहीं करवा सकते। कौन कौन सी? फर्स्ट ऑफ ऑल एग्जैक्ट लोकेशन ऑफ एन इलेक्ट्रॉन फाइंड करना, और सेकंड नंबर पे फ्यूचर ट्रेजेक्टरी ऑफ एन इलेक्ट्रॉन को फाइंड करना। ये आपके पास क्या हो जाएगा, इरिजिस्टिबल चैलेंज हो जाएगा। अंडरस्टैंड दैट?
Yes.
Okay, so how he describe his principle with the help of an example, with the help of an experiment. Imagine that you have a single hydrogen atom and you decide to observe the position of that single electron at a given moment. As we well know about an hydrogen atom, that hydrogen has atomic number only 1. Meanwhile, it has only one proton or one electron in its shell. Okay, so we have to predict the exact location of that electron which is present on hydrogen atom. Understand that? Shortly after you repeated this process, the electron moved to another position. Understand that? Meanwhile, this electron can move to another position of a shell. This means that from the original location to the next one is completely unknown to you. Are you understanding that? Meanwhile, we have no idea
Yes.
about his exact location. So continuous repetition of this process allows the gradual construction of a three-dimensional map representing the likely location where the electron is expected to exist. Hope so you have better idea about three-dimensional space. Meanwhile, one a horizontal rows that is known as x-axis, one vertical rows that is known as about y-axis, and the third one that is existing that space, this is known as about z-axis. Am I right? This is the
Yes.
three-dimensional direction which was hardly not discovered in Bohr atomic theory. Am I right? This aspect
Yes.
was not depicted in Bohr atomic theory, but the Werner Heisenberg is that scientist, is that German scientist who helped us to invent the three-dimensional structure of an atom as well. So that was his work. Understand that? So representing the likely location where the electron is expected to exist, you cannot know for sure where an electron is and where it goes next. This makes it impossible to draw the orbit of the electron around the nucleus. So that was about its uncertainty. As its principal name also contains the word uncertainty. We also know about the word uncertainty means we are not sure. Am I right? गैर यकीनी.
Yes.
We are not sure. We have not trust where the electron is and where an electron is going next. So that was the main concept of his principle. So in hydrogen, the electron has a potential to exist anywhere in the spherical region surrounding the nucleus. 95% or whatever you want of the time, the electron will be in a relatively simple region of the space close to the nucleus that is called as an orbital. So an orbital is the region of the space where an electron lives. We have also idea about an orbital as well, as we have read the definition of orbital in quantum mechanical model. Am I right? So that
Yes.
region in which an electron is probability found, an electron is probability lives, that region is known as orbital. So Louis de Broglie, another scientist named Louis de Broglie, a French physicist, in 1924 proposed dual nature of electron. What do you mean by dual nature? Mean double nature.
Dual nature and it is both.
Double
I don't think they put this. I don't think they put the spell of dual right. It's dual for dual, not due.
Yeah, but here is a word dual written. So dual nature means double nature of electron. Meanwhile, an electron is exhibiting two nature at a time. His first nature is like particle-like, whereas the second nature is wave-like. Understand that? Meanwhile, he says that Louis de Broglie, French physicist, says that an electron has two nature, and electron can exhibit two type of nature at a time. The first nature is about particle-like, and the second nature is about like wave. Okay, so he says that subatomic particles like electron can exhibit both particle-like and wave-like behavior. His idea opened the door for new possibilities in understanding behavior of subatomic particles. Enlist the name of subatomic particles kindly. What subatomic particles you have learned before? Yes.
I said
Electron.
proton, neutron, and electron.
Good. An electron having a negative charge, whereas a proton having positive charge, whereas a neutral having neutral charge or no charge, zero charge.
No charge.
Okay, good. So this concept made a significant contribution to the development of quantum mechanics. Moreover, in 1927, Davian and German experimentally confirmed the de Broglie hypothesis that electron has wave-like behavior. This discovery led to the formation for modern quantum mechanics. So that was the base which made the modern quantum mechanics as well as a famous theory, as a famous branch of the physics or chemistry for studying the subatomic particles, for studying the structure of an atom as well. Understand that? So what we have learned in Heisenberg Uncertainty Principle? Firstly, we have seen his work, his principle in 1927. Yes. Go through in your own words.
I'm saying his the Heisenberg Uncertainty Principle touches upon briefly in the concept that we can never know the exact location of an atom within an electron within
Mustafa,
an
your voice is
atom.
not clear to me.
Because if we try to
Mustafa, your voice is not clearing to me, bache.
then once we record the measurement, when we try to record the measurement again,
It's your internet connection too.
and then it would be within this.
Yes.
Okay. As I was saying, in the Heisenberg Uncertainty Principle, we learned that it is impossible to determine the exact location of an atom. Sorry, exact location of an electron within an atom.
Okay. So with the help of any
The
example of
example given
hydrogen,
here,
we have also
yes, ma'am, the
seen.
example given here is a single hydrogen atom. A
Okay.
hydrogen atom consists of one electron within it. If you try to note down the position of it, then in the second time you noted it, it would be somewhere else. It could be anywhere within the spherical structure of an atom. Hence, it is impossible to find the exact location or the future trajectory of the hydrogen atom.
Okay.
This makes it impossible to draw the orbit of the electron around the particle, around the nucleus.
Okay. Next, what was the work of Louis de Broglie?
Louis de Broglie was a French physicist, and in 1924 he proposed the dual nature of electrons.
Sure.
He said that an electron behaves like a particle and a wave both at the same time.
Okay.
He opened the door for new possibilities in understanding the behavior of subatomic particles. And in 1927, Davison and Germer experimentally confirmed that de Broglie's hypothesis was that an electron will have wavelet behavior. This
Good.
discovery laid the foundation of the modern quantum mechanics.
Good. And what was the work of Devian and Germer?
Division and Germer experimentally confirmed the de Broglie hypothesis that electron behaves like a wave.
Yes.